And I just have a quick poll. How many of you actually understood everything I said about generic operations on Wednesday? Or how many of you are still a bit blur? A bit blur, right? Okay, very good. That's normal. So very normal. Okay, so obviously I thought this is my 6th year teaching this class. Okay, and just after teaching this class 6 years, everything is very standard. Okay, because to be honest, okay, your batch is actually very strong compared to previous batches. I think when I talk to my tutors, I think your batch is really smaller than normal, but it's very strong. So I'm not too concerned. And actually, maybe because of that, I think the midterms are a little bit more challenging. Okay, but then I don't think so too. I think it's actually okay easy. But then your tutors say don't agree with me. Okay, so next week, next week, I will try to make it a little easier. But I would say that your batch is actually relatively strong compared to there are few weaker students. Okay, and the people who are a bit at the bottom now, basically we don't think they're weak. We think they're just a bit slacking. So we'll be kicking them. And every single one who is a slacker or we have signs that they are slacking, okay, I get reports. And I talk to them, right, Richard? Yeah. And then they realize, oh man, the prof is watching. And then, next lesson, this guy will be on the ball. Right? Yeah. So, yeah. So it turns out, after 6 years teaching this class, I have built probably the best, Big Brother, your Big Brother, right? Yeah. Big Brother system, I think on this system. So, every small thing that happens, I know. Scary, it's not scary, right? If you're stuck on the path, believe me, I know, okay? I know that many of you are stuck on path 11. Only 2 have finished, I think. Only 2 or 3 have finished. Let me say something about path 11 and 12. If you think they're a bit harder than normal, it turns out it's intentional. It's not my choice. Your tutors think you all need some mental or psychological preparation for the midterm. So they say, okay, let's give it harder to get in the mood. Okay, I actually agree with them, but then I quite democratic. So I say, fine, just do what you want. So path 11 and 12 are a little bit harder than normal because the tutors are trying to be kind. Really, they're trying to get you in the mood for the midterm. How cool is that? Okay, alright. Okay, so with that said, today what we do is this. Okay, like I said, I taught this class 5 times before. This is my 6th time doing it. At this point, about 30% of you knew exactly what I was saying on Wednesday. 50% of you are a little bit blur. 20% of you have no clue what I said Wednesday. So this is what happens. Okay. So the way you teach is that you tell them what you tell them. You tell them. You tell them. Okay. So today I will tell you again what I told you on Wednesday, just to make sure that the 50% that have a little bit blur will have more clues. The 20% with no clue will have some clue. And recitation we will try to figure out the rest. Okay. So anyway, today is actually a revision lecture. Okay, to be honest. Now before that, let me remind you that in about 12 days, okay, from now you have this fun thing called your midterm exam. It's very fun. Okay, guaranteed fun, guaranteed money back guarantee. All right. Okay, it turns out you'll be held in this place on Wednesday. Okay. And Mr. Zhe Yu, if you come late, sorry, no extension. Okay. Now another thing is those guys are okay. By right, you are supposed to leave this lecture hall 20 minutes before, right? You can do that, right? No problem. Okay, confirm can. All right. Now, so you although the exam is 1 hour 45 minutes, you are welcome to take 1 hour 30 minutes and go home. And go elsewhere. It's fine. Okay. I will not be offended. Okay, don't worry. Okay, you can walk out here. People like Kozi Tun will walk out 1 hour early last year. Okay, but then the point now is that you are allowed to leave early. Okay, and the exam is 1 hour 45 minutes long. Okay, latecomers will not have extra time. Questions? Okay, right. So this is next week. No, it's 2 weeks from now. Okay, so next thing. How will it work? Okay, you will have 1 times open sheet, which means that you can bring 1 sheet, double-sided, multi-column, font 2. Okay, I actually don't care. If you need to bring in microscope, you carry on. Okay, I don't really care. Now, let me explain to you the real problem here. Now, truthfully, my exams, I can do open book one, doesn't matter, because it doesn't help. But you know what? I don't do open book. Let me explain to you. There's logic, and I'm a very logical guy. Okay, open book has a problem. The students who are not prepared, they come thinking that, they bring a whole library here. Then you have one seat here, one whole stack of stuff here, then the fella, okay. Then the father students are doing the whole exam, flipping book. Thinking, hoping that it will help. I want to go now. Okay, so for your sanity and for your well-being, I have decided to bar that, right? And instead, I let you bring 1 times A4 sheet of two-sided, anything you want. You can go and type out Xerox, shrink down to whatever size, up to you. And the reason is the following. The reason is really that having open sheet pretty much forces people to go through and pick out what's important. Okay. Actually, nothing much is that important. I mean, everything must be in your head. Okay. And the best thing for you, I think Kozaha has very written on the forum. The best thing that you should do to come for exam is actually get a night's sleep. Okay. If you work till 4 o'clock in the morning hoping that it will help, probably will not. Okay. So this sheet is something that you can bring. Okay. Any questions? Will you provide the paper to do rough working on? The exam paper is one-sided, print out one side only. So plenty of space on the back side to do rough working. Okay. And plenty of space. Okay, now the thing is this, another thing is this, you see exam question, there's a lot of, it's like one big piece of space, there's only one big piece of code. It could be 2 lines of code only. So I put a lot of space in case you need more space, but actually, okay, let me explain to you. If you really know your stuff, and all you do is come in and write the exam, in 10 minutes you're done, you can go home. Okay, the writing, total writing time is only 10 minutes. That's why you know it's a thing. Okay, so there shouldn't be, there's not that much code, okay, although there's a lot of space. Okay, so I will try to do some paper, okay, but I don't think that's going to be helpful. And then the point here is that, you can write title if you want to, okay, all you cannot do is red ink, because I write red ink, hello. Okay, so you can use any color ink except red. You can use pencil. Okay, hope that helps. Okay, so scope is everything until lecture 10. But the interesting thing is that lecture 11 itself also nothing really new. The stuff that we're covering is just new concepts, but they are still using the old stuff. So to be honest, it's not very different. I have one at 10 sample. It's like really 10 year series. I think I have 10 years of exams inside the 10. I don't know, a lot of years of exams in the. Have you seen this? Who has seen the exams, the past exams? They're all there, right? With solutions, okay? So the point is that going through the exams will help you understand the kind of things to expect. But generally, the things to expect is unexpected. So I'm not sure it helps. But you understand why you cannot really prepare the exam. Okay, now why do you go through past exams? Because frankly, the whole point is to make you think, and you get a sense of what kind of thinking you need. So doing past exams is really practicing the thinking. All right. Now I would also recommend that you actually go and proctor yourself. Basically, this is the real exams, right? So you squat in a room. Okay, turn off the TV. Thank you very much. And also put away your handphone, right? And then you do for 1 hour and 45 minutes. Okay. And then you look at the solutions and see how. Okay. All right. So do practice. This is the general idea. Now, the midterm exam is set such that the very best students in this class will probably get 90 something. And the way they'll do it is they look at the question, they know exactly what answers you just write. Okay. About half the class will not finish some parts of the exam. I'm telling you, okay, I'm not telling you evil, okay, so you can write the form page if you want to, but this is how it is. Right, the point now is that once you get stunned the question, you start thinking and you spend 15 minutes thinking for the question only, you can't start. You won't be able to finish. Okay, the way to finish the exam comfortably is that you look at the question, you can't have the idea of how to solve the problem, you write down. Okay, so this is how the exam is being set. Okay, and so don't feel too bad. Okay, you do not have to solve every single question to get A in the class. Right? You just have to make sure that you solve enough questions to demonstrate that you've actually acquired the thinking skills that we expect. Okay? The guys who want to get A+, jolly well solve every single question. Okay? And it's possible. Okay? Now, so typically I actually have exam review on Monday. unfortunately this semester I'm teaching 2 classes. Monday nights I have a class as well, so I can't do exam review on Monday. So we'll do exam review on Friday next week, and we have it in seminar room 2, which is the room that is off near, on the 2nd floor. Okay. Again, in addition to your midterm exams, you also have exam review questions, which you can also try. Okay. And you are okay. So the way it works is this: we are not going to go through every single question in the exam review set of questions during the exam review, because it's a criminal waste of my time, your time. Okay. The answers to those questions will be given to you. So frankly, if you don't answer, you just wait, right? Now the whole point is that exam review, what happens is that y'all will actually okay. Many of you will not come. Many of you don't need to come. Those who feel like coming can come. Alright, those who come basically better come having tried the questions. Because what we'll do is that we will ask you question 1, how anybody has any questions? Confused? Nobody confused, very good, move on. Question 2. Alright. And essentially we will try to go through the questions you are stuck. Now, the thing about scheme is this, the problem that you need to deal with is not the answer. That means giving you an answer is completely useless one. Okay, let me tell you, before I even start, let me tell you what's happened. Okay, so I sound very evil, but this is going to be true. The exam will be such that you come here, you sit here, you feel very nervous. You open the exam booklet, you get stunned. Okay, and it depends how long. Okay, my point is that if you get stunned for half an hour, you're dead. Okay, hopefully you stun for not more than 2 minutes. Okay, after that you do your exam, whatever. Okay. And then you feel that many of you will not finish every question. And then next thing, the evil part is this: immediately after the exam, right? You go to IBLE, the solutions are there. And you look at the solutions and your jaw drops to the floor. And because the solutions are completely obvious. Okay, so welcome to 11S. This is going to be live for you. Okay, so don't feel too bad. This is normal. Alright. So the point is this. The point here to tell you is this: the solutions don't matter, right? Because oftentimes when I tell you the solution, right, it's like, damn, it's like, why do you think of it, right? It's completely obvious. See, the challenge in this class is not the solution, but you're getting to the solution by yourself independently. Okay. So on this review, right? Okay, what really is happening is this: you all must go and try, okay, and get stuck. Okay, the goal of the review session is to what? Is to start from where you got stuck and figure out how to unstuck you. Okay, I say again, the focus of this class has to do with the mental processes, how you think, how to rewire your brain. So giving you solutions is completely useless. I can do it right away. Okay, and you look at it, you're completely like that. I know it's obvious, right? But that's not the point, right? I say again, so you have, okay, in this class, if what you do is look at the question, look at the solution is obvious, you're screwed. You know what I'm saying? It's really the whole process is look at the question, try and solve yourself, get stuck, hopefully don't get stuck. Don't get stuck is good, then move on. You get stuck, look at the solution, figure out what it takes to get unstuck. Am I clear? Okay, it is the unstucking process that is really the crux of this class, and it is where your brain has advanced to the next level. Okay, every question the midterm is quite cute one, because I'm quite professional, quite pro already, I've done it many times. So every question has a certain thing that I'm trying to test you in terms of your thinking. Alright, and basically you can't do a certain question is because you haven't quite figured it out yet. Alright, but if you figure it out, you can do it. Okay? Alright, and the exact solutions that I'll post will actually explain to you, hopefully, what exactly I'm trying to do. Now, typically, okay, normally the exams on Wednesday, typically I'll give you back on Friday, but this year I think I'm not going to manage it, because my advisor is in town. My advisor will give a talk on Thursday, and then I'll probably bring her around. So unlikely I can finish grading by Friday. So this year, I suspect that you're getting your, I'll see how, if I finish grading by Sunday, then I'll probably get my tutors to hand out to you. Okay. If I can't, then I'll give you the graded midterm type by Wednesday, the following Wednesday. Typically, actually, I'm quite fast. Typically, I'll finish grading by Friday, but this year my advisor is in town, so it's a bit hard. Okay. So this is any questions so far? So this is next Friday, yeah. Now, okay. So frankly, on that week of exam midterm week, there's no DGs, no recitations. Okay. No recitations because I'm actually grading exam. No DGs because you probably be too, you may study for exam. Okay. Instead, what happens is this: instead, all all the DGs are converted into office hours. Okay, so the tutors who are on Monday, Tuesdays will be actually holding office hours in place of DG, or at the same place you have DGs. The two tutors, Tang Xiao and who Alex, yeah, they have been moved from Wednesday to Monday and Tuesday so that they can cover more time. Because quite clearly after exam, frankly, there are no business on Wednesday anyway. So might as well we move them Monday, Tuesday. Okay, we do this every year, yeah. So this is all very standard. So I will post this whole list on IVLE soon. Okay. Moral story is that Monday, Tuesday, if you get stuck, there's a lot of, there's no excuse. From 10 to 5 or 10 to 6, you have people who we can consult. Okay. So the resources we dump into this class is fantastic, right? Okay. Right? No excuse not to do well. Okay, we are here to help you. And don't be too concerned about the midterm exam, because midterm exam, there are people who will stun and don't recover. Okay, we have had a student. I think she's going to come here at some point. Because actually she stunned in the midterm and she got a B. Pretty much. She didn't do well at all. But she worked so hard. After that, she made up and got A+. And it was number 2 in the class by the end of the semester. Okay. It's a real person, real story. It's not making up. Okay. And she had no foreign background. She's a girl somehow. Sorry, I'm not sexist, but it's like that. Okay. So she had no foreign background. She's a girl, you know. She's still a girl. And basically, you know, she basically caught up, you know, with the rest, beat all the guys. The guys then got number 2 in the class. Okay. And then got A+. So it's possible. Alright, so next thing, okay, very fun. After this, we're going to play robots, okay? And for this, basically, I need you all to form teams. Please email your teams to Tang Xiao before the end of the midterm break, okay? If you all cannot do your matchmaking before that, we will do your matchmaking for you. Okay? 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 I didn't put out here, but can you please also give them a name for your group? Okay, name your group, whatever. Okay, any final questions? Alright, so this is the admin stuff. Make sure to keep you all, you know, kind of chill up. Now, today is just really revision of Wednesday. Okay, first of all, the general idea is this idea called generate operators, right? Which basically allows you to have procedures that can handle multiple representations, okay? And the general idea here is to shield the complexity of the underlying representation of the two different types of representations from the user, right? Okay, so the two key things are, first of all, you want to basically, right, allow the user not to have to worry about matching the data type with the procedure, okay? And number 2, you want to basically allow the code the code above not to make any changes, even if you change the representation. This is a very simple general idea. And this picture you saw, okay? And the key idea, let's say again, this is the key idea. So the key idea for this whole week is this idea of layering, abstraction layer. Okay? Now, 3 strategies to implement. First of all is this thing called dispatch on type, which is the simplest. This is something that you don't have to think about, you should know this. Essentially, you look at the data type, you do check the data type and call the procedure. Okay? So it's some kind of if else kind of statement, right? Okay, this is the simplest one. Now this is a bit new, this is called data directed programming, which is what we covered on Wednesday. Okay? Which is that you put these procedures in a table and you have a procedure that basically looks at rec procedure, right? And last thing is actually starting. Now this one obviously I covered like one slide on Wednesday, and most have no clue, but it's intentional because we will devote one entire recitation. Recitation 6 will, this is after midterm break, after the midterm exam. For entire recitation 6 will be devoted to this topic called message passing. Okay? So akan datang. Okay, so not to worry. This thing will come. I mean, after you teach this thing for like 6 years, confirm. Like that. I also don't know what to say. Okay, so the thing is next, after doing this generate operators, right, we can push this idea further. Okay, so today's example is a revision of Wednesday, and the way to revise is to show you a more complex example. Okay, the idea here is this. On Wednesday, right, we talked about how to handle 2 representations, okay, for the same data type. Okay, it's all about complex numbers, right? Now, the idea that we want to do now is this: how can you use generate operators to handle completely different data types? Okay, not just different representations of the same data. Okay, so how do you do this? Now, So the idea here is to do this thing called generic arithmetic. Okay, which means that we're going to work with rational numbers, complex numbers, ordinary numbers, and even polynomials. Okay, today you've not seen polynomials, but I was taught even 1 year, and it came out the exam. Okay, what so I tell you, right, you don't believe me, right, then I show to you in the exam. Okay, so you find it what exam papers are going to see it well, but so today's example you will see rational numbers, ordinary numbers, whatever. You will see polynomials, but along the way when you revise the exams you will find it somewhere. Okay, so it's real as well. Okay, and then the idea here is to support 4 different operations: add, multiply, divide, and subtract. Alright, so this was the old world. Okay, just a reminder. What happens is that the complex arithmetic package, which consists of these 4 operations, right, will call the generic operator, right, which is whatever, like add real, add imaginary, so get real, get imaginary, whatever. And then this operator will look at the data type is passed, right, and it will call the correct representation, either polar or rectangular, right. And then the operations are all contained in the package, right, and after the operations are done, okay, what happens is that you need to retag the data back to send up to the user. Why? Because the data that you've marked with, right, at some point the guy will take the data and pass it down again to do stuff with it, and when it comes down again you need to know what type it is, right? Okay, so now this is the bigger picture. Alright. Wednesday we were dealing with this part of the picture, right, which is that you go into complex arithmetic, you're doing this stuff, okay? Now today we'll go one step up higher, okay? Now we're going to build what you call the generic arithmetic package, okay? Whereby we are actually dealing with higher, let's just add, subtract, multiply, and divide. Okay? Now the idea is this, right? You have these four things: add, subtract, multiply, divide, right? In the normal ordinary numbers world, it's very simple. It's just these 4 symbols, right? You know this stuff. Okay? In the generic arithmetic world, it's those 4 symbols, right? Those 4 things, right? Because when you add 2 real numbers, it's just multiply, right? Imaginary numbers, you need to take different parts, add together, right? So it's a bit different. Now the add red and the round red, we covered it a few lectures ago, remember? So this is a big picture. Okay, so this is how it works together. Okay, and obviously at the bottom level you have all these primitive operations. This is what you saw last Wednesday. Okay, so what happens? Now the idea is very simple. The idea is that some program use some numbers, okay, and you will use add, subtract, multiply, divide on the numbers. Okay, and then it goes down to this layer, which is the generic arithmetic layer. Okay, and this layer has to do what? Has to look at the object type and figure out whether it is a rational number, whether it's a complex number, or whether it is an ordinary number, and then it will shove the thing down to the correct package, right? Now it turns out inside the complex arithmetic package, right, there are also 2 possible representations, either polar or rectangular. Okay, and what happens is that you need to go and send down to the right one. Okay, and then you will have to strip the tag. Okay, and then subsequently when you go up when you return the final answer, you need to retag the thing back. Okay, so what we do for this case example is that we again will use data directed programming rather than research and type. Okay, so recap. So this is the recap. The first thing, what is research and type? The idea is very simple. You go and write some kind of conditional statements. Okay, you check the data type. Okay, if the data type is of one type, you do something. If it's the other type, you do something else. Okay, now the problem with this approach is what? Name conflicts, sort of, but then you can change that. There's something, name conflicts, you need to change, you need to name all the procedures differently, correct? Second thing is that whenever you add a new type, you need to go back to the generic operator layer and start adding a new set of case statements, right? So the advantage of having the next thing, which is so this is the thing, and then you check the type and then you do the right things. Okay. Now this is actually the data directed programming, whereby you actually put all these procedures in the table, right? So the advantage of this second approach is that when you add a new data type, nothing changes, right? The operator layer remains the same. All you do is you put new entries in the table, and everything works for you. Okay. So by doing this, we are able to make it simpler. Okay. Now, so these are 2 basic operations that you deal with when you deal with tables. Okay, the put and the get operation. All right, and what we do is that we index this procedure is using what? The name of the procedure that we want to get, and also the data type. Okay? Okay, any questions so far? Okay, once you have all these procedures all put in the table, right? Then a generic operator looks like this. Okay, real part Z will be what? Get procedure, get real part, the type of the data, and then if the procedure, it comes back, right? Now, so what to do? This let does this table operation. It tries to get at this thing and returns as proc. The implicit implication here is that if you get something and you can't find it, what happens? What does it return? No, not error. No, something. It returns false. Okay. So the idea here is that this get the table, right? You do a get. If you actually have something there, you return the procedure. How cool is that? If not, it return you false. Okay, that's why I do an if proc here. See, because we know that if it's not false, it's true. Okay, so if it's false, then you get error, right? You print error. But if it's not false, that means there's some procedure. Then you apply the procedure on the content. Okay, simple. So this is how you would write a generic operator that basically doesn't have to change, right, when you add new data types. Okay, now, so next idea. So obviously you can do real part Z this thing. You can do imaginary part Z this thing, whatever. Okay, you can keep doing this, right? It turns out that you can, because of the fact that if you want to do this for all procedures, the code looks the same. What's the key idea? If you have many pieces of code that look the same, except for one small part, you will abstract out the thing as a higher order procedure, right? Okay, so this is what we were doing last time. Okay, so again, and then in the end we create this thing called apply generic op dot arc. Okay, and Mr. Eugene Ang, right, complained to my tutor and I talk about the dotted tail notation. This dot thing is a dotted tail notation, which I covered on saying, because you will probably not pay attention, right? Okay. So this thing is the dotted tail notation, this dot. Okay? And what happens is that this dot allows you to take in what? An arbitrary number of arguments. Okay? So apply opt dot arc means what? Means that apply a generic must take at least one argument, which will be opt. Now, everything else will be shoved into arc as a list. Okay? Alright, so this is what happens. So what happens here is the following. Now, so once you do this, okay, first thing you do is type text, map type text on arc. What does type text do? Type text is a car, right? Some sort of car, right? You just takes out the first thing, which is the text. Alright, so the type text is actually a map of this car, this is a car-like operation onto arcs. Now, why is that map? Because arcs can have multiple pieces. Okay, because you see, I'm applying an op on something. Okay, in this case, how many things? One thing. But later you will see procedures which are like add, which will apply on what? Two pieces. Right, so that means the arcs then would be two different objects. Right, and so when you do type text, the map, you come out two objects. Complex or something. Okay, now once you know what's the object type that you're dealing with, what do? You go to the table, you get op type text. The op, right, is the what? Is a name operation. Okay, so this op here is the name of the operation that you want to execute, and type text are the types of the objects, the data objects that you're dealing with. Then you again check whether this procedure exists. If it doesn't exist, you will do error. If it exists, you do what? You apply proc to the map of the contents of arc. Okay, map is some kind of querying operation. Essentially, you go and extract out the content part into a list. Okay, so apply proc something is the same as proc something. Okay, so again, apply does what? Apply plus scheme as it. Apply plus list 1, 2, 3, 4 is the same as plus 1, 2, 3, 4. Are we clear? Okay, this is revision on what we covered on Wednesday. Just make sure you understand. So one thing, this is done, then you can do the following, right? So this all your generic operators. Okay, last time, okay, this is the obvious way of doing it, right? This is now a bit less obvious way of doing it. Basically what I've done is that I've converted this whole thing into a higher order procedure called apply generate. Okay, and this is how I'll then write all my procedures. Are we clear now? Yes.
How come for your prop you can let prop get an operator and then a list?
Right?
I thought previously it was just text, but now it's a list of text.
Kind of.
So you replace all the things.
No. The thing is this, the mapping of this thing, previously this is a tag. But nobody stopped you from having this thing as a list of tags. Why? What's it wrong? This is just an arbitrary thing. I can call David also can.
But let's say you have a list of tags, then, and your tags are different. So one is
different,
so you get back a list of different props.
No. This is used as an index. Right. So it hardly matters as long as it's unique. I can have this thing as one item. I have this thing as one list of 2 items. It doesn't matter. It's just like it can be like can be 一尾苏 or 一尾丹 or something like that. So it means this will be one identifier of 2 pieces. Means the surname and first name. You don't have to be one name. Don't have to be, just your name can have a surname, you don't have to be one name, you know what I mean? So this is like basically you don't having this as a multiple items or one item doesn't matter as long as unique. This whole thing is a name. Okay, later you'll see, okay? So so you're clear what happens, right? So I think last Wednesday we were not too clear about what is going on here when I went through generic operations. But now I'm explaining more in detail what happens. That's why it's written this way. Okay? Means it doesn't have to be written this way, but because we see that it is all the same kind of code, we can make it a higher order procedure. Yes? Anybody else? Ladies? Yeah. No, not you. Yeah.
So is prop an operator or a list of operators?
Good question. Is prop an operator, list operator? Prop has to be operator, right? Because you're going to apply the prop on something else, right?
You get a list of tags.
No. You get this thing, right? You're right. This is a list, right? But I'm not using a list as a list. I use a list as a name. We are obscure. You carry this first. No worry. Okay, now let's take a look. Okay, so anyway, this is Ben's. Remember, this is Ben's package from last time. Okay, these are all the operations, no change. Okay, now this is what happens. This one is where you put all the stuff into the table. Right now, what happens is that I have the name of the operation. I have all the list of the types. Okay, now these guys are all rectangular one. Why? Because all these procedures only takes one argument. Okay, KIV first. Okay, for now. Now, similarly, Alyssa is here. This is the polar side. Okay, I put in I put in these operations into the table, and the type of the tag is polar. Okay. Now, this is not the. Okay, this is again still revision. So why we do this is because now all these operations are internal. Okay, to the installation procedure, so you can't be seen. There's no conflicts. Okay, it's fine. And I use tags to distinguish these types. Now this is where the new world starts. Okay, so what I have here is the complex package. Okay, and obvious to you, add complex is what? You make the complex number, right, consisting of what? You add the real parts and add the imaginary parts. Agree? So all these things are common sense. This is what you know, what you learn from math, right? And then you do division, you do what? Division, you deal with the magnitude and the angle, right? Okay, so nothing is new here. Now this is where the magic happens. Okay, now sorry, this one this is imported from the packages. So to do this thing, to make a real from to make a complex number from real imaginary parts, essentially I will import the constructor from the rectangular package. And where's constructor? Constructor is gotten from the table, right? I get this operation for the rectangular data, and then I can apply this. Okay, now the next thing is this. This is where the magic happens. So you look at the add, right? When I put add, I put add into the table and I add complex. Okay, what I'm saying is this. What I'm saying is that if I'm dealing with two complex numbers and I want to add them together, then obviously I will take out this thing. Okay, essentially I will apply complex, which is here, and then after I'm done with that, I will tag it back. Okay, the tag is a complex tag, so the data that has been dealt with is actually a complex number. Yes.
What if you're not dealing with two complex?
Then is somewhere else. Then you have to be something else. So you need to have add like complex real or something like that.
Won't your table be like long?
Correct. Okay, so obviously there's cost to it, but you're right. I mean, they're bigger. You put more stuff inside. Okay, but anyway, I'm almost there, but not quite yet. So far, you all understand. This basic part has to do with putting stuff in the table. Okay, that will tell you what operation. Okay, and what sorts of data types you're dealing with. Okay, now, so the first thing you realize is that now there are actually two tags per data type, right? There is a tag that tells me that this thing is a complex number, and there's a thing that tells me that this thing must be it's in rectangular form. Okay, so this side there are two tags. Okay, now the first tag, the complex tag, is just to tell this layer which of the three you must send to. Right. Now, complex says that you need to send to this package over here. And then after you have the rectangular tag, right, which tells me which of these two representations we need to send to deal with the operation. Okay, these are two tags. Obviously, you can have more tags than this. Okay, this is this idea of the layering abstraction, which is very important. Okay, and what it does is that as data passes down a layer, okay, you add some more stuff, okay, and then as the data goes up the layer, you get rid of stuff, okay, and this is applicable to other areas, especially this thing called component networking. Okay, many of you doing 2105, which when you will deal with the network stack, okay, and in this is a bit reversed, okay. In the network stack, as you pass down the layer, a tag is actually added, and as it goes up, it's removed. Okay, so it's somehow converse. But it doesn't matter. Just to understand that this layering idea, okay, is actually quite important and can apply to other things. Okay. So far as Wuni, no, David, right? You were saying, right? So far we will do complex. What happens if you want to do complex and real number? Well, it turns out that one thing you can do is to create this dynamic table whereby you have got complex, real complex, whatever, or rational. Another way of doing this is this thing called coercion, okay, which is actually to force one data type into another one, okay. And the general insight here is that there's actually a hierarchy of numbers, okay, of the following sort. So essentially, integer is a rational number. A rational number is a real number. Real number is a complex number, okay. And the general idea here is that you are able to coerce a so-called lower type into a higher type. Okay. However, you will not be able to coerce the opposite. You can't convert a 3 plus 4i into an integer. It's going to be a problem. Okay. So generally what happens is this. Okay. If you have data types of this kind of different types, okay, what you do is that you have a function that converts the lower type into a higher type, and then you use the higher type operations to operate. That will prevent you from having this explosion. Okay. Okay. More details here. All right. So summary. We use general operators to provide a kind of a layer. Okay. And what we're doing now is that we want to. The whole point of this lecture is says that you can use this technique not just to handle different representations of the same data type. Okay. We can also use this to basically allow us to manage different data types, okay, in a kind of visible way. Right. Next, okay, the key advantage of this thing called data-directed programming, which is the putting of these things into a table, is that it keeps us from having to deal with this problem of name conflict. Okay, and coercion is used to basically change, not change that, it's actually, you actually represent a low data type into a higher one. This allows you to use the high data type operations to actually manage them. Okay, okay, so how many of you think it's still blur? Blur, right? How many? Don't be shy. How many? Wow, 30-40%. Okay, still sorry. Okay, how many completely clueless? One. Completely clueless, one. Okay. Okay, not too bad. So I reduced the blur ones from 50% to about 30%. Clueless ones from 20% to only 1. So this lecture is quite good. All right. Now, the thing is this. Obviously, after this lecture, it still seems very abstract. Okay, and I've done this for 5 years already. Cannot be helped. Okay, so how? We will use missions 12 to 15. Okay, to solve this problem. Okay, and this issue tomorrow. Okay, and this will really help you understand. Now, the thing is that missions 12 to 15. Okay, essentially will make you go and implement rational numbers, complex numbers. Okay, and then the whole point here is that you will then have to do this coercion stuff. Okay, so you'll do it in code. Okay, you have to do the tagging and untagging. You'll be asked why must tag, why not you tag, whatever. Okay, and then once you actually do it in you will be able to hopefully understand this very well. Okay, so okay, this concept is quite abstract. Okay, but that's the nature of the work. Okay, next thing. Okay, tomorrow. Okay, before you complain, sorry, I did so many times I know. Okay, most times, how many missions you get? One mission at a time, right? Tomorrow Bonanza, you have like 5 missions at one time. How fun is that? Okay, and the reason is the following. The reason is this. It's not random. Okay, the reason is that we have covered all these materials. Okay, so that means in theory you can do all the missions. However, between now and 2 weeks from now, you have midterm exam. Okay, so some people may want to go and do missions. Some people want to start the midterm exam. We are very democratic. Leave to you. Okay, so we let you have all missions. Okay, the due dates are not on the same day. Due dates are staggered. Okay, and it will be like after the midterm exam. Okay, why are you laughing? It's true. Okay, now those of you who feel like learning complex numbers can go and do the missions early. Okay, and be done with it. Those who don't think about it can forget about it. Go and study midterm exam. After midterm exam, try to remember it. Okay, hardly matters which way you do it. Okay, but this is how it's going to work. Okay. Okay, with that, okay. And any final questions before we go? Yes, Samantha. You go back.
Last lecture, I thought you said when you put back up the layers, right? The tags are reattached. How about now it's...
This question, right? Excellent question. Okay. This one, okay. So let us observe, right? Okay, the question is this: why is it that I'm saying this in reverse? We said earlier in this whole general operations, right? When you go up, you reset. Okay, when you go down, you strip tags. When you go up, you put back the tags, right? That's what you said, and it's correct. This thing I'm talking about is not referring to this specific example. I'm actually referring to computer networking. Okay, in networking, you have exactly the same kind of idea. Okay, and it turns out that in networking, when you go down, you actually put tags. When you go up, you strip tags. Okay, now why that is so, you don't have to worry yet. I'm just saying that, I'm just highlighting that the principle here is not more general than what we're telling you. Okay, in this example where you have these layers, the reason is very simple. The reason is the perspective of where it's up, where it's down. Okay, the real reason is this. Okay, in this particular example, I have chosen to do this way, so going down and going up has this effect. It turns out that if you look at the networking world, then the perspective up and down are reversed, and so you have this thing about things. So it doesn't matter. The whole point of this idea is that you have layers. Okay, as you go through in one direction, you will put tags. As you go through in the opposite direction, you will strip tags. Okay, then the question of which side is up, which side is down, depends on where you come from. Right? Some parts of the world, you know, this side is up, the other side is down. Other parts of the world maybe it's reverse. So that is matter of perspective. Okay, so up and down is not a fixed thing. Any other questions? Okay, if not, then I wish you all a very I would say good midterm break. I sense out that you have a lot of stuff to do for the break, and some of you I'll see on Friday. Okay, Friday, next Friday. Only sign up if you really need to come, okay, and you get stuck. If some of you are very good students, you all can clear all the review questions, please don't come, waste time. Okay, stay home, sleep some more, go watch a movie, probably that's more good for you. Okay, and before the exam, please do not go and study the day before the exam. Okay, the night before the exam is time to sleep. Okay, yes, do you have anything to say? No, what are you here for? OS, Oh, okay. Alright, so the tutors have a lecture here after this. Any final questions? Okay, if not, enjoy yourself. This midterm break. Congratulations on surviving till half time. Okay, good day. Bye-bye.
I had a topic concerning apply. I'm not sure exactly what apply does. In the list, how does it, because in the past...
No brainer. Okay. Apply from some stuff equivalent to pop stuff. Ta-da! Done. There's no brainer one. It's just like that.
But then, okay, and
everything says you know. Apply prop on some stuff is the equivalent of prop on the stuff equivalent.
Okay, so and in that case, the definition of the prop should be of the form.
You better make sure that prop can stay in the. No. If the prop only can stay in one argument, you apply prop on a many argument list, what happens? Pick and die normal it's the same thing
So it has to be of this form.
No. Then the prop can be of any form. The prop is one argument, two arguments, but you don't make sure that you apply, you know how many arguments you have. So, okay, what happens is, suppose I do lambda x something, right? Say I do full, define full with this. Okay. Can I do full 1, 2? I can.
It's taking only one argument. How can we do it?
You can do that. You shove it in there. If it mismatches, you click in like error. So similarly, you can apply. You can always apply. Whether you die or not, it just depends on whether you can match the argument. So if you want, it's up to you. You can always force the prop to apply to anything you want. But if you apply the prop to too many things, then the thing will die.
But still, in that case, how do I define the prop? And in what way will the prop consider all the arguments? Because the arguments are inputted into...
The prop is any prop, you can start anything you want. No. The arguments of prop is not this. The arguments of prop is actually this thing. That means, I say again, let's say...
Okay, how will it handle it? I don't understand how to define it.
The prop is any prop, anything. So just understand that if you apply prop, okay, A, B, C, D. You can have A, B, C also. Okay, this is equivalent of prop A, B, C, D. Oh, it's equal to that.
Okay, I understand that, but how do I apply it? I mean, how do I define the prop in that case to handle an arbitrary number of that?
Then arbitrary first, then you define, arbitrary first, you use the Dr. Taylor notation. You define, to be dot stuff of the body, right? So what happens now is that when you apply, so when you do full AD, then what happens that this AD will go into use as AD.
Okay, and in that case, it will have a null at the end. It will have a null at the end because it will be proper. It will have a null at the end because it will be a proper list. Proper list. Okay.
Then you just put a dot here, the dot with this.
Because actually what happened was I didn't quite understand this, and the way I saw it was that basically apply is doing something on a binary operator, and it is continuously...
Apply does this, no brainer, no things hard. Just apply given a list is equivalent to this thing. Now this whole thing is completely separate from this whole thing, right?
Okay.
Apply is completely companies that apply is just taking this thing and applying to this thing. Has nothing to do with this thing at all.
I was completely confused earlier. I think I understand now.
It's completely separate.
Yes. Because that's why I tried so many different solutions to that part where apply was used, and I had absolutely no idea how to fix it. But I can do it.
Yeah, so this type tag is a list of text wrap.
Yeah, I won't worry about it. You do machine solve, it's awesome, you know this by heart. Yeah. Okay.
No. How is this looked up in the table when you apply a list of text?
You look up like just like a tag lah. I mean, this whole thing is
a tag.
Think of it as a string lah. The table look more complete than this, right? The table look like, 2 things, 3 things, whatever. I mean, instead of putting one thing there, it's actually what you see is actually a list. Okay, I won't worry about this at all. You do constant, you will know this inside out, you know this downside, inside, out, outside, in, whatever, confirm, no problem. This is all very abstract, but the point here is that you just think of this table, and then you have 2 things or 3 things. How to explain to you, this is best to do. But like I said, I'm completely not concerned about this thing, because you're all forced to do solution solve to 15. After that, it's going to be crystal clear, because if you don't get it crystal clear, you won't be able to do the mission. So, but y'all will do the mission because you don't want to get it right. So when that happens, because you're dealing with the actual thing itself, you can see how the operations work. So the table gives you. Essentially think of it as, don't think of it as a list, think of it as op and another string. So the list is relevant. It's not a list, it's not really. It's just a lookup thing to look up.
Okay.
Using the mic, right? This one? Yeah. Why?
Small table. This one.
How you doing?